Alright, so you probably fall into one of these three categories. The first is that you're not really familiar with plugin architecture or plugin frameworks yet. The second is that you've been watching my videos on plugin architectures, plugin frameworks, AutoFac, Blazor, and how all of this can work together, and you've started making your own applications with a plugin architecture. And the third category is that you're very aware of plugin architectures, but when you were looking at the pros and cons, you said there's too much complexity that can arise when you're trying to put all these plugins into an application and figuring out how that's actually supposed to work in production. Now, for the folks that are in category number one, you can go watch some of my other videos first, so I'll put a link up there, and you come right back here and keep watching. And for the folks in categories 2 and 3, the reality is, yes, plugin architectures do actually have this drawback where the complexity can grow a great deal. Especially if you're not really familiar with plugin architectures or you don't have a lot of experience doing this, there are things that you could be doing or might not be doing that aren't really setting you up for success. Personally, I think the pros outweigh the cons, but the reality is, yes, complexity can leak in when you're using plugin architectures. And this arises because there are so many discrete things that have to be brought together to make the whole application work as a whole. And sure, yes, you might not need all of the plugins to have the application work. It could function with just a small subset of them, but when you're shipping it to customers or you have customers using a live service and you expect these plugins to be active, this is where the complexity can arise. In this video, I'm going to walk through a project that I have and go through the different code organization and how I have different things broken out into plugins. From there, I'm going to explain how I've introduced some types of tests that I think really help me get an idea for how things are functioning, but we're going to zoom out from there and see how we can apply this concept in general for different types of tests that might not fit in a traditional sense. With that said, let's jump over to Visual Studio and see what's up. Alright, so I'm here in Visual Studio and I'm in my Calorate solution. Calorate is the solution that I have for my service for nutrition that's called mealcoach.io. I've shown this in a couple of other videos, but this is one of the services that I'm working on sort of on the side outside of work as a passion project. Now, in Meal Coach or in the Calorate solution that we have here, I have this folder that's called microservices. And it's worth calling out that it's called microservices, but the way that my application actually works is that it is more like a modular monolith. And by that, I mean that I don't actually have separate microservices running. I actually just deploy everything as a monolith. However, everything that we see in this microservices folder is a standalone independent type of service that could exist, but I have it all integrated into one. And if that sounds a little bit confusing, I'm just going to throw out that they're all plugins. And because they're all plugins, I can dynamically load them at runtime to get the functionality that I expect to have in my application. And without getting into the details, this really just means that my application that I end up launching is really just a shell application. It doesn't do very much at all, but what it does do is load these plugins, which actually are responsible for the bulk of the logic that the service has. And that means if I really just wanted to have, for example, a hello service, well, I could actually just stop packaging all my other plugins and just have a hello plugin, and my program would actually launch and I'd have a service that really just says hello. But because my expectation is that my Meal Coach service actually has all of these pieces working together, and I don't want to deploy them separately, I do have all of these plugins bundled, and they get deployed together. But because I have all of these plugins in this folder, when I do want to go run my service, I want to make sure that everything's actually configured the way that I expect. And if I go back to the example I just made, I don't just want to have a hello service. I want to make sure I have a hello service, a job service, a meal plan service, so on and so forth. My expectation is that all of these services are available, and that must mean that I should be able to check the plugins that I have to make sure that I have access to everything that I expect here. Okay, so I want to pause for a second because if you start to conceptualize this, this might seem a little bit backwards from all of the benefits that plugins really give us. Plugins, in theory, should allow us to extend an application without the core application having to know about anything to do with the plugins. And I still think that's true. That's really the goal here. When I go to add a new plugin, in my case, it's a new service that I want to extend as part of my main offering, I don't want to have to go touch the core application or some other service, any other part of the code to make it work. I just want to add the new plugin. So when I'm talking about checking a configuration for my core application, It sounds a little bit backwards that that configuration test and my checking to make sure I have all the plugins I need, it sounds backwards that it would be able to know about that. Because shouldn't we just be able to add plugins dynamically? And this is just one of those times where it comes down to use case and being pragmatic. In my situation, I don't have plugins that are created from a third party, and I don't have plugins that I need to actually load dynamically as the service is running. Really, I have plugins just to give me, as the developer, the flexibility to land features without having to disrupt anything else. I also leverage plugins because in the future, if I do want to move to microservices or have some other way that I package these things together, maybe some of these services don't always make sense to be grouped, then I do need to kind of modularize them and separate them. I have that ability built right in. And I think that's an important call out. I'm not using plugins to extend it to third parties. I don't need to worry about that. It's really just a convenience thing for my development. So, what are the implications here if the core application or some part of the core application must know about all of the plugins? Well, let me clarify because it's not actually going to be the core application that needs to know, it's the tests for the core application. And more specifically, the integration tests I have when I go to test that core application. In a lot of my content, when I talk about testing, fundamentally, it always boils down to having confidence in the changes that you're making. And for me, when I have all of these tests for all my different plugins and they're addressing how that plugin works individually, when it comes time to actually testing the core application, really for me, that comes down to making sure that the core application has all the pieces that it needs. And if we go back to what I said earlier, my expectation for the core application is that it has all of these pieces that I've introduced. So the way that I've approached this is essentially that I have a set of tests or a style of tests that almost act like a manifest for what I expect to have in the core application. And that means if I have an expectation of the different plugins that should be there, then I can run different tests and different checks to make sure they're behaving as I'd expect. This does seem like it goes a little bit in the face of some of the other plugin things that I mentioned, like being fully extensible, because yes, if I go to add another plugin and I want to go extend the core application, I don't have to go touch the core app, but I have to go touch the functional tests if I want to make sure that that core application is tested accordingly. Now that means depending on how I've set up my tests for the core application, I could have it such that it remains brittle, and if I add a new plugin that's not expected, those tests would fail. The other way to do it is that if I add a new plugin, none of the tests fail, it's just that I don't have that extra coverage that I would expect to check for that plugin. Now, what's right and what's wrong? Well, that's totally up to you and your use case. But for me, the way that I've approached it is that I'm not protecting against extra plugins. I'm protecting against making sure that plugins don't actually break what's already there. And that includes this set of tests. So if I were to add a new service, I don't want my integration test to break, but it will mean that I have to go back to these tests to make sure that I have coverage over this new plugin. Now, that's probably enough rambling and talking with my hands, so let's get back to Visual Studio, and I'll show you what I mean by one of these tests. Okay, so back in Visual Studio, I'm going to go to Configuration Tests, and you'll see that this file is actually inside of a project called Calorate Web API Tests Functional. And Calorate Web API, so this project right here, is actually the entry point to my service. So this is really just the functional test project for that service. Now this test file actually only has one test, but if I go to explain it, the pattern should be applicable for other types of tests that I'd want to create to give me the coverage that I want on my plugins. So before I jump into the test case itself, I just want to talk about some of the setup that I have here, because this is a pattern that I've shown in other videos, and your situation might look different than this. In fact, the code I can guarantee will look different, but the actual process and thought behind what I have here might be very similar. So what I'm doing in this case is making sure that I can stand up an entire application so that I can resolve all of the dependencies properly. And I need to do that because I'm going to be checking for plugin information. If I were to use things like mocks and kind of take shortcuts just to be able to get instances to things, they're not going to represent the real things that I need in my application. So what this code does is actually inject some of the pieces that I need, like a SQL database and a MongoDB database. So these will actually be containers that go run where the tests are being run. And then this code here in the constructor is just a builder pattern that I've created that actually allows me to set up an API client to talk to an actual server instance that's running. And again, I'm not going to go into all the details on how and why this works, but what I'm able to do at the end of this is basically resolve dependencies out of a dependency container that is based on a real running application. Okay, now to look at the test. Now, this test here looks like an absolute mess, and if you're going, holy crap, you're right. This can definitely be improved, but let me explain what's going on. The purpose of this test is that I actually have different plugins that I need to look at, which is why this list is so long. And what this test does is ensure that I have caching enabled in all of the places that I expect it. Now, fundamentally, to go check if I have caching enabled, this could be done in a ton of different ways, depending on how I have things configured. But for me, the most effective way, because I'm using AutoFac, is I want to make sure that the actual references for the types that I'm resolving are exactly as I'd expect. So if we look at the different types that I have as part of this inline data list here, we can see that I have things like a user with metadata repository, a user repository, user auth repository, and a whole bunch of different repositories. And the reason I have these here is because each of these repositories actually has caching that I want to ensure is enabled. Now, in order for this to work, yes, it does mean that my test project actually has to reference and know about the different plugins. So that's a little bit messy, totally agreed. It doesn't have to work this way, but what I could also do is leave it dynamic so that I don't really need the references to the specific types, but instead I have some other way to go resolve the types and maybe just use some manifests that can look things up by name. These things would still be coupled together in the sense that I need to have knowledge about the different plugins that I want to test. However, I wouldn't have a hard dependency on the actual binaries to be able to do this type of referencing here. Now, the reason this works okay for me is because I'm taking a shortcut with my plugins. I actually do reference all of my plugin projects inside of Visual Studio, inside of this Calarate Web API project. And I do that because, like I said earlier, I'm not actually trying to deploy these things as microservices. I'm just trying to get the advantages of having all of these pieces separated. So by referencing the projects, I actually get the convenience of being able to press the play button in Visual Studio and have all of the binaries copied, and generally everything works as I would expect. In your environment, say you have a bigger team or you have multiple teams in your organization working in an application that has a plugin architecture, this totally might not work for you. In fact, you might have different build systems building each of these pieces, and then those pieces are getting dropped into a different directory at build time or deployment time, whatever. But in my particular case, I have this shortcut where I do have all of these binaries accessible to me. Now, the point that I'm trying to make with a test like this is that I actually have patterns that seem to go a little bit against all of the other things I was talking about with plugins. And you're probably wondering, well, why? Like, why would I do something that seems to go against the pattern? But it's to demonstrate to you that when I'm trying to build confidence in the things that I'm creating, I'm trying to be pragmatic about what I'm doing and looking for things that seem to work. I've already mentioned to you as I've explained this that there are opportunities that I could refactor this out, go build some type of manifest where I can have text-based lookups and check all the types, so on and so forth. But that's just extra work at this point. It will literally offer no value to me if I go do that when I already have it working like this. If there's a point in the future where I need to break these dependencies and I can't actually have this project referencing these other plugin projects, then certainly I can go look at refactoring this. But what this test is affording me to do, and this style of test would afford me to do, is actually ensure that my main application is configured to use plugins the way I would expect. So this test in particular, like I was mentioning, is just looking at caching being enabled where I would expect, but I could also just go write a test that basically iterates over all of the plugins that I expect to have available. So if I go back to the left here in the Solution Explorer, I could go double check to make sure I have a plugin for each one of these folders. That could easily be another configuration test that I could go run and would absolutely offer value. To explain why that offers value, One of the things that I added most recently was actually this hello service. If you recall, I mentioned that the project, Calarate Web API, must reference all of the services that it intends to have integrated into it. If I forgot to include that reference, I'd have compiling code here for this hello service, but it wouldn't actually end up in the bin directory ever. If I want to ensure that that's done properly, I could absolutely go write that test that I was explaining and make sure that I can resolve a type or some other check to ensure that I have access to that service being resolved when I would expect. And there's lots of other things you can consider here. So for example, if you needed to have your plugins load in a particular order, if you needed to make sure that in certain situations like debug versus release that things were excluded or included, you could absolutely write tests that check for that. But again, I'm using patterns like this that seem to go against plugins because they're giving me the confidence I need that my core application is configured how I would expect. So bringing the conversation back to complexity, and for folks that might not really be into plugin architectures, just because there is so much complexity, I wanted to showcase that you can actually take a different approach with your testing that might give you some of that confidence back. Now, the cases where there is going to be a lot of complexity probably don't align to the pattern that I just showed you because you'll probably have different teams that are delivering plugins, and some build system or continuous integration system is going to ensure that those are dropped in the right spot. It might look very different at different places, of course, but when that kind of thing happens, what kind of test do you want to have in place to make sure that things are operating as you'd expect? The way that I had the test set up in Visual Studio that I just showed you may not work because you'd have to have references to those DLLs. If you're dropping them in dynamically and you don't have a reference ahead of time, that's probably not going to be the solution for you. However, you might be able to implement something similar to that and actually have a harness that goes and resolves the plugins that you'd expect. Back to that manifest idea I was talking about, maybe where you actually have a list of the plugins in text form or the path to the plugin, ensuring that those are loaded, and you could do checks to make sure that they do resolve properly. And realistically, this might be a test that you can't go run in Visual Studio. Depending on what your organization looks like, how your project or your service is set up, this might be something that actually requires a build system to put these pieces together before you can go run a test like this successfully. To have it run in your local environment in Visual Studio, it would mean that you need to be able to pull down these other pieces. So say other teams' plugins, their services, whatever, they would have to be dropped into something on your computer. I personally don't have to deal with that in my current case, so that's why my approach to this works the way it does. But if you want to apply a similar technique, the point that I'm trying to get at is that you might need to consider that this is a type of test, some type of integration functional test that runs in your continuous integration system and not actually something that you just go press play in Visual Studio. So to summarize this, yes, plugin architectures can absolutely add complexity into the services and the projects that you're creating. And one of the ways that we can try to have confidence with all of this complexity is by writing tests. But the style of test that we might want to write to give us that confidence back might not feel like the right thing to be doing because it seems to kind of go against some of these patterns that we've been exploring with plugins. The idea that plugins can just be dropped in and things work and you don't have to touch any, central code or configuration anywhere, that seems to be something with plugin architectures that we really want to have. But when it comes to testing the configuration of all of these plugins working together, the reality is that centralization, that idea that some central thing needs to know about the configuration, that seems to shine through. And if you can kind of work past that mentally, then you can start to think about solutions where you say, well, if I have something central that seems to know all these plugins are needed, then I can start making solutions for that. And one of the ways that you can try to work past that is consider the fact that if you or someone else knows all of the plugins that are needed, that's already a central thing that knows about the configuration. Why can't you codify that? Why can't you put that into a config that can be consumed? So this was mostly just a thought exercise to get you thinking about how you can actually work through the complexities of plugin architectures by writing tests that look at your configuration. So if you've been building out an application with plugins, if you're reaching the point where you're going, I wonder how I'm going to test if this all works, this might be the next perfect step for you. And if you're someone that was saying, hey, I don't like plugin architectures, way too complex. I'm hoping that this gave you some insight into how you can look at writing tests to actually check that that complexity is in order. So thanks so much for watching. I hope you enjoyed, and we'll see you next time.